Today we'll be graphing piecewise functions. Our learning targets: when given the piecewise equation on the left, we can graph the function on the right. Let's recall what a piecewise function is. A piecewise function is made up of pieces of different functions which are the result of their different domains or their different x values. These are not inequalities. There are no shading or any dashed lines. This is a different type of function made up of pieces depending upon their different domains. Example 1. So we want to graph this piecewise function. Notice inside the function I've got two separate linear functions followed by a comma and a domain set. So for all x's that are less than 3, okay, for all x's that are less than 3, so from this point, that direction, I'm going to graph the following line, y equals 1x minus 4. Well, let's first start by graphing that line. Okay, so this first line, I start at -4, and I have a slope of 1. However, I can only include x values that are strictly less than 3. So if I go on the x-axis, the x value of 3 has an output of -1, and it does not include that point. So I need to grab my eraser and erase everything to the right of that dot. Okay, so now I have that line. So that's the first piece of my function. Okay, it's the line y equals x minus 4, but I only include x values that are less than 3. We can do our next line here. Okay, y equals -2x plus 1, so my y-intercept is +1, and I graph a slope of -2. So I go down 2 over 1, down 2 over 1. Okay, it may be easier to wait and graph the line until we realize what the domain is. The domain, my possible x's, are all x's greater than or equal to 3. So on my x-axis, I go to 3, and if I look down to the ordered pair, where x is 3, y is -5, and it can equal that point. So that's going to be a solid dot, and it's everything greater than. So greater than is to the right on my x-axis, so I'm going to draw my line just to the right for my domain. Okay, I'm going to erase everything else to the left of that line. Okay, so I have now graphed that piecewise function. I've got two pieces. The first piece includes all x values all the way from -infinity to 3, and it doesn't include 3. And the second line includes all x values that are greater than or equal to 3. So that piecewise function gave me the graph that is now shown. Two more examples, the first of which includes an absolute value function. Let's remember that inside the parentheses, if I have a subtraction, that moves my vertex to the right 3. Okay, and my everything else is the same as the parent function, so I'm going up 1 over 1 in both directions. Let's take a look at our domain for this guy. Okay, it's all x's that are strictly less than 5. So at the x value of 5 on my absolute value, I'm going to have an open circle, and it includes everything less than. So I can draw my line to the left. All x values to the left. Okay, so there's my first piece. I'm going to do my second piece in blue. Okay, And this goes back to a linear function, y equals mx plus b, where my b value, or my y-intercept, is -2, and my slope is up 1 over 2. Up 1 over 2. Okay. Again, looking at my domain, it's all x's that are greater than or equal to 5. So at this x value of 5, okay, I'm going to see where my line would be. Well, it would start here and include that point, and it is everything greater than. So I can erase everything else to the left of that point. I now have my two pieces. My first piece was an absolute value function, including the domain, all x's less than 5, strictly less than. And my second piece of the piecewise function was the linear function 1/2 x minus 2, including all of x values greater than or equal to 5. It looks a little messy. You could clean it up on your page just by keeping the solid circle with a nice line off to the right. Last example, okay, this one looks a little different. It's just a constant value for 3 different pieces of a domain. Okay, well, remember that f of x, it's a fancy y equals. So I have the line y equals 3. It's a horizontal line at y equals 3. That's the first part. Okay, but my domain is the x value from 0, non-inclusive, to 2, inclusive. So I only keep the values in between there. Okay, it is just that little piece. Okay, next one, the horizontal line at 1. Okay, so we did our first one in blue. I'll do my next one in red here. Okay, again, the line y equals 1 is a horizontal line at 1, but I'm not keeping all of it. I'm keeping from 2 to 4. Okay, 2 can't equal, it is strictly x is greater, okay, and x is less than or equal to 4. Okay, and I said x is greater because if we break this guy up, okay, my first inequality, x is greater than 2, and my second inequality, x is less than or equal to 4. Okay, so that tells me that my line lies between those two. It's all x is greater than 2 and x is less than or equal to 4. We got one more piece to this piecewise function. It's the horizontal line y equals 5, but my domain tells me to keep x's from 4 exclusive to 6 inclusive. So that piece would look like that. Okay, and notice it looks like different stairs. Okay, it kind of looks like some stairs. So this is called a step function. Okay, a lot of times you'll see step functions that look something like this. Okay, in this case it looks a little bit different, but in general it looks like stairs. So that's called a step function. That's one of our other special functions. Okay, so that is a step function. That's it for graphing piecewise functions. You'll see many more examples in assignments, but that's a few different basic ones that we will see most often. Thanks for watching.